Okay, so I'm finally on to the second tutorial. I think that I've got my audio and video issues worked out. And now I want to talk about passwords. So, um, we were always given passwords and told to memorize passwords, and there's all sorts of issues. But we don't. We need to think about passwords in a realistic way. And one of the things is that all of you have way more passwords than you could possibly keep track of. One of the design principles or cybersecurity first principles is process isolation. We don't want the compromise of one process to result in the compromise of the entire computer. Same thing for passwords. So we're, I guess, going to abstract process isolation to passwords. So we don't want to use weak passwords. We certainly don't want to use the same password for more than one account. And we don't want to leak your passwords by letting other people see them. So know that if you sign up for a site, it is very likely that that site is going to get hacked at some point. So you don't want to expose your more valuable credentials to the sloppy security of your weakest site. So we're going to create a place for all your passwords on your computer. And we're going to use the Unix standard password manager. It's already been installed. And that's called Password Store. But the command for everything is called pass. So I sometimes refer to it as Password Store, sometimes refer to it as pass, but it's the same thing. And we're going to keep all of our passwords in encrypted files. And we're going to encrypt them by creating a hard cryptographic key on the computer. This is how governments and big corporations keep things safe. It was invented by academics, but it was implemented by the Free Software Foundation. Actually, it was implemented by one particular individual named Philip Zimmerman, who is a very interesting character, has written some wonderful stuff, and I've included in a lesson plan, my lesson plan, not Scott's design thinking stuff, but my sort of raw lesson plan, some references to it. But cryptographic protocols is one of the areas where students, professors, nobody can ever have enough math. It uses analysis and algebra and number theory and algebraic geometry, and so it's beautiful, really beautiful math we're not going to get into here, but you can know that you can never have enough math for it. Okay. So we're going to go through how we would install a GPG key on the computer so that you can initialize the password. So the first thing that you want to do is type GPG -- key. Sorry, gen key. And we're going to choose RSA and RSA. There are other options here. I'm not going to go into the difference in the math between them, but we're going to choose one. We're always going to pick the longest key possible. The longer the key, sort of like the longer the password, the more secure, 4096. We're going to choose that the key does not expire. We're going to answer yes. And we're going to put in a name here. And so for me, this is my computer. I already have a key set up, so I'm going to put in phony name, but you may want to put in a real name. You can always get rid of these keys later. So I'm going to say em1@gc.com. or I'm going to say Evan M, and then email address is going to be em1@gc.com. Okay, this is a fake key. Okay, and we're going to say that that is, I'm going to quit here. You would say that it was okay. All right. We're going to skip the secure passphrase, and I want you to think about what implication that has, and what would happen if we put in the secret key. All right. So now we're going to use this GPG command, and we're going to list secret keys, and we're going to say how we want them listed. Key format is long. And of course I can't spell key ID, not key format. And so I have an existing key. My existing key is Evan Mashula. Your key will be the one you just generated. And you can see that the key ID starts with a C here. I'm just going to highlight it. And so that is my key ID. Okay. So to initialize password store, you're going to type pass init. Now for me, I would just use that key. So I would get by doing and I would initialize a password store. You put in your key. All right. So with password store, each password lives inside of a GPG encrypted file whose file name is the title of the web source or resource that requires the password. So that is difficult to unpack, but as soon as you see it, it will be obvious. So remember that there are hidden files on your computer. Password store is hidden. It's a configuration file, but it's available. So if we do ls passwords, you can see that it's just a directory, and it has a bunch of other directories and files in it. Well, maybe it would be more obvious if I used some of the flags from last time. So if I do LHA capital F space password store, you can see some of these are files and some of these are directories. And nobody can read, write, or execute them but me, because I'm the owner. Now, all right, so, well, what happens if I try cat on my AWS password? So let's CD into the password. So even though it's hidden, you can still CD into it, right? If I do present working directory, there I am. And what if I do cat aws.gpg? I get a whole bunch of mess. That's because it's encrypted. But if I use pass on it, I can get the file. So let's do one thing before I show you, before I make you believe that I actually know what I'm talking about. So let's just type pass. If I just type pass, it gives me this nice tree structure of what my password files look like. So I have an academic directory in there. I have GitHub and HackerRank and Hashtag, OSI and Postgres. I have an AWS password. Okay. So if I want to see what that AWS password is, remember I tried to cat it, but it didn't work. But if I type pass, pass is using my GPG key, and I say pass AWS, it gives me the password. I'll be changing that one. Okay. Now, what if, all right, so that gives me my password, but that's not particularly useful. That would be really, really hard to type. Okay, so let's say I want to put in a password, right? So in social, I wanted to put in a new password. So pass, insert, social, Facebook. So do you want to overwrite it? You could overwrite it, put in a new password. I'm not going to overwrite my current Facebook password. All right, now, you can have folders for your parents' passwords, your house's passwords, your school passwords, your siblings' passwords, all of the stuff that you need. And it's all reasonably protected. Okay, but how do we use this? So let's say I want to log into my Facebook. So I'm gonna go over here to Facebook. I'm gonna log out. Right? Log out of Facebook. Now I'm out of Facebook, right? So get my username. I go back to my command line and I type pass-c social Facebook, and it copies the Facebook password to the clipboard. And for the next 45 seconds, it's in the clipboard. Then I can go to the password, just hit Control-V, paste it, and log in.